For centuries, we've fantasized about alien life on other planets. And because life as we know it needs water, we imagined seas on the moon, rivers on Mars, and lakes beneath Europa's icy surface. So far, we've discovered only dust, except on this watery blue marble, where inner space hides creatures as weird as anything extraterrestrial. There are oceans of oddballs, with strange shapes, strange rituals, and strange bedfellows. Right here, in Earth's own alien abyss. Our oceans are constantly changing. For billions of years, volcanoes, asteroids, and ice ages have kept marine life on its toes. If you want to live, you've got to adapt. No solution is too strange if you survive. That's the origin story of every watery weirdo in the sea, beginning with the very earliest. We've had life in our seas for 3.5 billion years. But intelligent life? Not so much. If Martians had visited the Earth way back then, they might not even have recognized it as life.
Lower landing leg. Turn on your magnascope to third power. How primitive.
In the beginning, all life was too small to see, except for these living rocks.
Hello. Take us to your leader.
These are stromatolites, the oldest surviving life forms on our planet. Colonies of bacteria that have been around for 3.5 billion years. They don't do much, except survive. Stromatolites ruled the oceans for most of Earth's history. Now they survive in only a few spots, like Western Australia's Shark Bay. The bacteria cells stick to each other and the seafloor with mucus. Sediment gets stuck in the mucus too and starts to smother them. The bacteria live by photosynthesis. They need sunlight. So they migrate upwards, out of the muck and into the sun, building rocks at 0.5 millimeter per year. Stromatolites and other single-celled creatures had the sea all to themselves for about 3 billion years. But eventually, bigger things came along. Things that liked to eat them. Thus began the familiar food chain. Stromatolites, plants, and anything else that can photosynthesize get energy from the sun. Herbivores like this dugong come along and eat them. Then carnivores come along and... yeah, you don't want to see that. Back to the stromatolites. Sadly, most of them got eaten by things like sea urchins. But a few survived thanks to their one superpower. They can live in extra salty water. That's why today, you'll only find stromatolites in tidal pools, which, thanks to evaporation, are twice as salty as the sea. Too salty for their enemies. The march of evolution was tough on single-celled creatures, but it made life on Earth a lot more interesting. It gave us weird beasties like the red-lipped batfish and the tasseled wobbegong. To make animals like this, you need over 100 different kinds of cells, with each kind of cell doing a special job. That is, you don't make the tassels with the same cells you use for the gills. The very first animal to crack the multi-cell formula was this. No, not the frogfish. That's hundreds of millions of years in the future. The thing he's pretending to be. The sponge. Sponges were the weirdest thing to happen to life on Earth since, well, the beginning of life. An animal with no organs, no tissues, no nervous system. But a big leap forward all the same. The first creatures with different cells for different jobs. Example: sponges make egg cells and sperm cells for reproduction. Eggs they keep to themselves. Sperm they release in a cloud to share with other sponges. They also have an outer layer of cells similar to our skin. And hidden inside, a layer of different cells to filter bacteria from the water. They are herbivores, specializing in microscopic food. Jellyfish are some of the first multicellular creatures to turn their attention to hunting. The challenge is how to hunt with a body that's 95% water. The solution? Keep it simple. Their bells are a jelly held together by thin membranes. A ring of muscles around the bell contracts to force out water. The first jet propulsion system. But their biggest innovation, microscopic, neurotoxic darts. Nomura's jellyfish is king of them all. Arguably the largest jellyfish alive. It's the size of a fridge. Nomura's jellyfish plies the Yellow Sea between China and Japan, always searching for food. This giant beast is stranger than most. It has hundreds of mouths, all over the big feeding arms below the bell. Its little fishy friends are safe though, as long as they avoid the many long, thin, stinging tentacles. Nomura's mouths are only 1 millimeter wide. Only zooplankton, teensy tiny floating animals fit through. But every one of them gets stung first. It's mass murder on a microscopic scale. If gelatinous stinging aliens freak you out, get ready for some bad news. Humans are doing everything we can to make more of them. We pour nutrients into the sea, creating plankton blooms. We catch the fish that would eat the plankton, leaving more food for the Nomura. We've given them an opportunity to launch an alien invasion numbering in the hundreds of millions. How can they take over so fast? Jellyfish can clone themselves. Their larvae attach themselves upside down to the sea floor. But they don't just grow up to become one adult. Each larva creates many identical copies of itself. In just one generation, they can launch a clone army. If conditions are favorable, and they are, the jellyfish population explodes. If this sounds terrifying, this type of thing has happened many times in Earth's history. 500 million years ago, there was such a massive burst of life that we named a time period after it. The Cambrian explosion. A time when evolution itself blew up in all directions. New animals tried out wacky new ways to live. Some of their experiments really stood the test of time. The most successful invention was a basic body plan. Suddenly, alien animals start looking eerily familiar. Meet the bilaterians. A big word for animals with a top, a bottom, a left, and a right. Essentially, anything that's not a sponge or a jellyfish. Bilaterians include dugongs, remoras, scuba divers, and sharks. Sharks have been around for 350 million years, in a form we'd recognize today as Sharky. You know the drill. Nasty teeth, slicing fins, dead eyes, and that streamlined torpedo shape. But one design is just plain weird. Why, Hammerhead? Why? Separating the eyes at its wingtips gives the hammerhead extraordinary stereoscopic vision. But it does nothing for the hydrodynamics. All the spoiler does is increase drag and spoil the sleek torpedo shape. Hammerheads are 10 times less energy efficient than the classic shark silhouette. So why has the weird head survived? It acts like a forward rudder. The slightest twist creates a very sharp turn. Perfect to chase down rays. Its favorite, but very tricky, prey. But the strangest shark of all has almost given up on swimming. This is the epaulet shark. Its other name is the walking shark. The ones living on Australia's Great Barrier Reef have developed extraordinary abilities to dice with death. Their home is shallow and highly tidal. It's easy to get stuck in a small pool at extreme low tides. The water temperature can skyrocket. Oxygen levels drop by 80%. The death zone. Solution? Just walk away. Fins with extra muscles and a greater range of motion are almost as good as feet. But even this low-tide specialist can run out of pools, out of air, and out of luck. Now it shuts down much of its brain. Brains use a lot of oxygen. Heart rate slows, blood pressure crashes. Essential systems only, until tide comes in. Engage brain and walk away unscathed. Back to the alien abyss. Feet, or fins, are not the only way to walk. The seafloor abounds with many peculiar pedestrians. Animals have adapted all sorts of appendages to do the job. Sea stars have hundreds of tube feet, which are for breathing, smelling and tasting, as well as walking. Sea stars don't have brains, so every tube foot makes its own decision on where to go. It's a miracle sea stars move at all. And bristles can be legs too. Bristleworms are highly successful, with little more than a head and a whole lot of identical segments. The biggest bristle is the bobbit, a bizarre brute up to 3 meters long. You heard right. If you're swimming in Indonesia, beware of 3-meter-long walking worms. They're killers. The bobbit is too slow to run prey down, and it's oblivious to the ones that hide. But it has big ambitions. It has its eyes set on a fish. Wait, it has no eyes. How does a blind, slow-moving worm catch a fish? Watch. The bobbit burrows tail first into the sand and deploys its alien apparatus. 5 surveillance antennae tuned to any movement. Razor-sharp, spring-loaded mandibles primed. It's barely visible. The slightest touch sets off the trap. The muscled jaws can slice big fish in half. The worm retracts into its burrow, dragging its prize to a grisly end. Compared to the ruthless bobbit, its cousins, the tube worms, are, well, feather dusters. They're bristleworms that have become builders. They hide in hard protective tubes attached to any suitable support. Instead of spring-loaded death traps, they extend crowns of other worldly feathers. A marine multi-tool that they use to breathe, find food, and gather building material. The fine feathers sort the stuff that floats in the water. Large bits they reject. Small bits they funnel to their mouths to assess as food. And middle-sized sand particles are just right for sticking together with mucus to build their tubes. The Mediterranean fanworm is the most successful of them all, or the most invasive, depending on your point of view. You'd think a sedentary worm living in this idyllic place would stay put. But it's the pretty fanworm, not the vicious bobbit, that has conquered our planet. They're incredibly fast-growing and their larvae can settle on anything, including passing ships. They've hitchhiked from the Mediterranean all the way to New Zealand, on the other side of the world, and taken over at 1,000 per square meter. Once established, they're almost impossible to get rid of, thanks to a few secret weapons in their quiver. They absorb heavy metals, like arsenic, from the seawater and concentrate it in their crowns to deter predators. Stranger yet, they have simple eye spots all over their feathery mouthparts. Any sign of danger, like the shadow of an approaching camera operator, and they retreat. Eyes. Now that was a useful development. All animal eyes have a common origin, going all the way back to the Cambrian. Starting as simple eye spots, they developed in many bizarre ways. From the relatively simple eyes of the scallop to the sophisticated compound eyes of the mantis shrimp. But the eyes of octopus, squid and cuttlefish are out of this world. Maybe. Meet the headfoots. Cephalopods, if you want to get all Greek about it. The basic blueprint, tentacles, and a head with big eyes. Eyes with freaky features like the ability to detect polarized light, or to focus independently of each other. Some squid eyes even have built-in lights to see in the dark. Basically, it's the recipe for a real-life alien. And some say that how cephalopods got to be so weird is a genuine deep space mystery. In 2018, a few scientists suggested that octopus eggs might have come from outer space, frozen on a comet. Sadly, all the other scientists said they were tripping. The conventional, less exciting wisdom is that cephalopods and their eyes started out much simpler. More like the nautilus. These are the most primitive surviving cephalopods. They're the only ones that still have an external shell. And the only ones without amazing visual abilities. 500 million years ago, 2,500 nautiloids ruled the ocean. Today, just 6 remain. The South Pacific's pearly nautilus is the largest. Like Captain Nemo's submarine, the Nautilus sinks by filling chambers in its shell with seawater. It can sink an impressive 800 meters before its shell implodes. But its eyes are much less impressive. They are open to the sea, with no lens or protective cornea. Unique in the animal kingdom, the Nautilus eye is basically a pinhole camera. The image that pinhole pupil creates is 400 times less bright than that produced by octopuses. But at least it was a start. Later, cephalopods, like octopuses, added lenses and other features to make their eyes state-of-the-art. They're a very different design to those of vertebrates, but just as successful. They don't have different color receptors on their retinas. Instead, they seem to see color by splitting light into its components with their strange horizontal pupils. And instead of changing the shape of their lenses to focus like we do, They move them back and forth like a camera. It means their ability to focus never deteriorates. But great eyesight is only one reason that they're brilliant hunters. The other reason is their phenomenal brain, which is unlike any other on Earth. This is a run-of-the-mill common octopus. Its central brain has decided it wants to check out some other rock pools. It's instructed the 8 auxiliary brains to make that happen. They're all working on the problem independently, one brain in each arm. 2/3 of the octopus's brain cells are in its tentacles. They may even be helping to process visual information. They could be seeing with their arms. One thing the octopus still can't do is breathe air. It's breathing from water stored in its mantle. It has 2 hearts dedicated to pumping blood to its gills. The 3rd heart supplies the organs. Maybe they really are aliens. Or just an incredibly over-engineered solution to the problem of how to kill a crab. In the oceans, problems are just opportunities waiting to be cracked. For some of the most alien life forms, no problem is too extreme. Earth is a planet of extremes. There are places where no sensible life form should survive, like hot acid lakes, or the depths of the abyss. But even here, life has found a way. Quick recap. If you live on Earth, you're probably getting your energy from the sun, directly through photosynthesis, or indirectly. If you're not, then chances are you're an extremophile on a hydrothermal vent. Places we've only known about since 1977, when we started exploring the deepest parts of the ocean. Everything down here is more alien. Even the octopuses. The water temperature is near freezing. The pressure, immense. Volcanic vents pump out superheated water and noxious chemicals. And vent shrimp wouldn't have it any other way. They thrive in the Goldilocks zone, between boiling and freezing. In fact, they're unusually active for deep-sea creatures. The question is, where do they get their energy? They get it from extremophile bacteria that use chemicals from the vents as their energy source. It's chemosynthesis instead of photosynthesis. The shrimp don't eat the bacteria. Instead, they receive nutrients directly from bacteria actually living inside their guts and on their gills. This is life completely independent of the sun. Many scientists now think life started in this dark, hot chemical soup. It may be that learning to tolerate the sun was the real alien innovation. Off the coast of Taiwan, there are very shallow hydrothermal vents just below the surface. They belch out superheated water and a lot of gas, mostly carbon dioxide. Warm, acidic seas, high CO2 levels. Sound familiar? Scientists love places like this. It's like studying the end result of global warming. Life, on the other hand, hates it. Super sulfur vent crabs are the only creatures that can hack it here. Among other things, they've learned to metabolize sulfuric acid. The crabs have evolved special biochemistry to cope with CO2 levels that kill all lesser creatures. Anything that asphyxiates becomes crab food. Most of their meals are much smaller than a lost pufferfish. Plankton dies the moment it drifts into this watery hell. All the crabs have to do is pick it up. They thrive in conditions where nothing else survives. But that's hardly surprising. Crabs do well almost everywhere. So much so that many imitators have tried to follow their recipe for success. Crabs may look a bit like alien robots made from spare parts, but their sturdy design has stood them in good stead for 200 million years. With 8 legs, massive claws, body armor, 360-degree vision, and amphibious capabilities, they are the perfect planetary rovers. Maybe that's why nature has thrown up the crab body plan many times over. This is a crab. 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 Not a crab. 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 Not a crab. Yep, that's a crab. And not a crab. This porcelain crab is an extreme example of carcinization. That would be the tendency for crustaceans to become crab-like. Porcelain crabs are a family of squat lobsters, squashed up and flattened. King crabs are relatives of hermit crabs, which, by the way, are also not crabs. There are many advantages to being crab-like. It's easier to hide under rocks or in crevices, and you expose less of your vulnerable side to predators. The crab-eyed goby is obviously convinced. It's done some carcinization of its own. But no defense is perfect. For extra protection, many crabs augment their armor with elaborate camouflage. Others carry defensive weapons. And the king of all crab-like things has become so big, no one bothers it. Coconut crabs are the world's largest hermit crab. Again, not really a crab. There isn't a shell big enough for an adult female to hide in. Instead, she has hardened plates for protection. She can breathe air through primitive lungs. So she has no need to return to the sea except to release the eggs that she carries under her tail. When they're ready to hatch, the ocean calls her back. She may be a landlubber at heart, but her offspring start life as beach babes. They'll have to take their chances with the tides. The point where the land meets the sea is a great place for extraterrestrial sightings. In a sense, sea creatures that come ashore really are aliens. The action of waves and the coming and going of the tides catch many a careless creature unaware. One tidal terrestrial has not only adapted to these hardships, it's based its entire life around them. The finger plow snails of southern Africa are confirmed beach bums. As the incoming tide flows over the sand, plow snails emerge by the hundreds. They've avoided the low tide, hidden under the sand. Emerging on the incoming tide means they don't run the risk of drying out. But they have an unerring nose for any unfortunates left stranded at the high tide mark. But how to get all the way up there, traveling at, well, a snail's pace? That requires genius. These snails have sails. They unfurl their freakishly big feet to catch a wave all the way to dinner. Time for a bit of alien probing. The long, maneuverable proboscis searches for an opening. Once it's in, the snail hoovers up soft tissue and liquid up to 1/3 of its own body weight. Fully sated, they wait for the retreating tide to take them back to where they started. The sneaky snails successfully straddle two worlds. Why choose when you can have the best of both? Mud skippers have raised this dual citizenship approach to an art form. From Africa to Australia, these enigmatic little fish are waiting for low tide. They all have joints of a sort in their fins that function a bit like elbows. It's what puts the skip in their step and helps them keep their heads up high. Some of these proud land dwellers spend 3/4 of their time out of the water. And they're not lying around gasping for air. These little oddballs love to throw their weight around. Some fight for mates and territories. Some turn into formidable land-based predators. Others graze on the nutritious slime the tide leaves behind. Lots of highly active stuff that uses up a lot of oxygen. The weird thing about mud skippers is that they can't breathe air, at least not directly. Like all fish, they have gills. But they can also breathe through their skin, like amphibians do. To do that, they have to keep it nice and moist. The inside lining of those giant mouths is especially good at absorbing oxygen. Some mud skippers love air so much that when the tide comes in, they take another big gulp to fill up their burrows with a pocket of air. Incredible as they are, mud skippers have never really conquered anything more than mud. Leaving the sea for good would take fundamental changes to the way animals walked and breathed. The first animals to take up permanent residence on the land were fish. Not the modern fish that we have today, but ancient animals called lobe-finned fish. The most famous is the coelacanth, extinct for 50 million years, until someone fished up a live one in 1938.
The coelacanth is a fish with arms and may prove to be the link between man and his sea ancestors.
We now know that the closest living relative of land animals is the only other type of lobe-finned fish, the air-breathing freshwater lungfish. Even today, you can see how its prehistoric relatives might have crawled up a mudflat. Paired fins eventually became the arms and legs of land animals. Lungfish do have gills, but their environment is often low in oxygen. Gills alone won't cut it. Lungfish must surface regularly to gulp fresh air at the surface. These strange fish have a pair of lungs very similar to our own. Of course, things were different when their ancient ancestors slithered out of the water. Today's lungfish face a problem their forebears never did. Land-based predators. The shoebill is just another creature that evolved from that pioneering fish. Once animals had conquered the land, there was only one thing left to do. Head back to the sea. What a waste of time that was. Yes, otters are the descendants of homesick landfish. 5 million years in the sea have given them webbed feet, paddle-like tails, and waterproof fur. But they wouldn't look out of place on land. The reason is that, in evolutionary terms, they haven't been back in the water all that long. Given more time, the transitions get a lot stranger than these oversized water weasels. Whales are most closely related to hippos. A penguin is a fat albatross with tiny wings. And the dugong is a cousin of the hyrax. But the animal voted least likely to succeed at sea lives here. The Galapagos Islands are famous for their bizarre animals. Blue-footed boobies, giant tortoises, tropical penguins. Charles Darwin, famous scientist, made his name studying the least interesting inhabitant, the finch. The coolest, most alien creatures he dismissed as, and I quote, most disgusting, clumsy lizards. The only thing he liked about these imps of darkness was that they tasted good. Harsh words for the only lizard to have reinvaded the sea. Marine iguanas are so completely bound to the sea that seaweed is the only thing they eat. The bizarre thing is, they're not really much different to the neighboring land iguanas. They're all iguana and very little marine. So how does a cold-blooded lizard that moves slowly in full sun turn into this alien action hero? The big males feed exclusively beyond the surf zone. The water is cold. Every stroke saps his energy. Now he fills his lungs and, battling his own buoyancy, dives 10 meters or more. Finally, food. Anchored with his sharp claws, he grazes quickly before his body freezes up. Underwater, they're not as stupid and sluggish as Darwin thought. The clever iguana times his return to the surface so that he has just enough energy in reserve to make it back to shore. When he reaches the warm basalt, it's all he can do to lie, spent in the sun. Now his black body comes into its own. It's important to get warm as fast as possible, because there's one last thing that makes these iguanas weirder than any alien. They can't digest the only food they eat, at least not on their own. They rely on bacteria in their guts to break down the tough seaweed, and they only work when they're warm. He just musters up the will to sneeze out some salt, extracted from his blood by a special gland. Meanwhile, his land-based cousins haven't even left their cactus. The two species are so similar, they can breed to produce hybrids. Marine iguanas really are land iguanas with strange habits rather than strange features. Swimming. Compared to land iguanas, their toes are minimally webbed. Their tails only slightly flattened into paddles. Holding their breath? No special adaptations here. You can hold a land iguana underwater for an hour without killing it. Please, take our word for it. Both types switch to anaerobic respiration when the air runs out, even though land iguanas seldom need to. And this trick? Most lizards have salt-removing glands. In fairness, marine iguanas do have the best salt glands of any reptile. The amount of salt they eat would pickle any other lizard's kidneys. All in all, their adaptations are mostly behavioral. They time their excursions with the midday sun. They leave hot, come home cold, and spend the rest of the day recovering and digesting. Sometimes an alien is just a normal creature exploring a strange environment. It just needs one to take the plunge. The ocean was the cradle of all life on Earth. The place where fundamental new designs were first tried out. And it's still the place where some of the wackiest evolutionary experiments get tested. Animals will do anything to exploit an opportunity. You may end up as one of the ocean's oddballs. But when you win, no one cares what you look like in the alien abyss.